All right, so we're going to do some warm-ups for the Chapter 8 quiz. So we're going to take a look at a few of the things that we should be able to do for the first couple of sections here. So this will give you a little bit of an overview of what we're going to be looking at. So let's talk about rational exponents first. So this idea of a base being raised to a fractional power. Remember our conversation about the bottom number is always going to be the root. And then that top number is always going to be the power that that's raised to. So we want to be able to rewrite it as a radical to make it a little bit easier for us to do it in our head. So when we think about what this would be as a root, so this is the root and the bottom number is cube, so cube root of 64, and then we're taking that answer and we're raising it to the fourth power. So you being able to understand what that fractional exponent notation means is a really big part of that idea. So let's go ahead and simplify that. It's making the number smaller first. So cube root of 64, that means what number times itself 3 times, right, gives you 64. So you have your nice power table that you can look at. So find that in your cube root. That is a 4. And then we need to take that to the fourth power. So 4 to the fourth means 4 times 4 times 4 times 4. And again, you can look at your perfect fourth table. See if you can find that. 4 to the fourth is 256. So it's an easier way to do that calculation without having to try to think of that fractional power all as one entity. It's a little bit easier to deal with. All right, so same idea for the next one. So 27 to the 2/3. Go ahead and pause the video and see if you can figure out what that would look like. So go ahead and see if you can rewrite that one as a radical and then come back for the explanation. All right, so we got a root of cube, and then that's going to be squared. That's the power you're going to be raising it to. So when I rewrite this as a radical, I am going to, oops, it's not 64 again. It is 27, and it's a cube root. And then remember that whole thing is being raised to that power of 2. So we start on the inside and work our way out. So cube root of 27, what times itself gives you 27? That would be 3. And then we need to square that. So 3 squared would be 9. So being able to simplify a little bit easier. All right, same idea for the next one. Just be really careful on what your base is. So again, go ahead and pause the video, see if you can rewrite it, and then we'll come take a look. All right, so remember again, bottom is the root, and then that numerator is the power, so power of 1. So that makes it a little bit easier. So we have our base, everything that's inside the parentheses. So that is that whole negative 64. So it's got to think about it. This is something that's going to be legal to do. We need to take the cube root of that and then raise that whole thing to the first power. So when I see negatives under the radical, I worry a little bit, but cube root totally fine, because a negative times a negative times a negative will give you a negative 64. So that's completely legal to do. So that's going to be what number times itself 3 times? Well, that's a negative 4. So it's a negative 4, and then we have to raise it to the first power. So because it's the first power, then our final answer is just negative 4. But have to be careful about what can we take the root of and what can't we. We can do odd roots of negative numbers like that. It's totally fine. All right, let's take a look at the a little bit more of the exponent rules now, and some interesting things that can happen with these rational exponents. So for the next one, we're going to try to do dividing. And remember, when you divide two things with the same base, what do we do with those exponents? Well, we subtract them. So we would be doing 9/4 minus 7/4. And I know that looks really goofy, but we can subtract fractions. It's no big deal. We know how to do that. Denominators have to be the same. So we have 9 take away 7. So that would be 2/4. And again, always simplify if you can. So 2/4 would be the same as the 1/2 power. So if I want to leave it as a rational exponent, I can just go ahead and leave it as x to the 1/2. That's totally fine. Remember, if you wanted to write that as a radical, remember that bottom number is the root. I could write that as the square root of x to the first power, or just square root of x. So both of those would be completely legitimate ways to write that. But we're just doing the same exponent rules. It just so happens that there was a negative or a fractional exponent that we had to work with. All right, let's take a look at number 5. Again, dealing with a fractional exponent, but now a negative. So let's see if we remember what that negative means. Always means reciprocal, right? So being able to understand that that negative exponent doesn't mean a negative answer. It means reciprocal. So we're taking each of the things in that fraction to the negative 1/2 power, means they're going to go in the opposite location. So that means that 9 to the 1/2 is going to be in the denominator, and the 25 to the 1/2 is going to be in the numerator, each thing to that negative exponent. So I like to deal with those negatives first, get things where they belong. And remember, for fractions, we can do the top and the bottom each to that power, so it's a little bit easier to do your calculation. All right, so remember what power that is. This is your root, right? They're both square roots. So this is basically saying, hey, what's the square root of 25? and then over the square root of 9. It's a little bit easier to think of it that way, the 1/2 power. So negative made that reciprocal, and then we do our square roots. So square root of 25 is 5, and square root of 9 would be 3. So we can get all the way down to 5/3. Just remember, when you have that that ratio inside, everything gets raised to that power. So we can do that power for both of those terms. All right, last thing we're going to talk about is back and forth between radical and rational, and just simplifying a little bit. Remember, we can always reduce and break things into pieces whenever this power underneath is bigger than the indice on the outside. So what this means is, what's the 4th root of x to the 12th? That means taking x to the 12th and dividing it into 4 equal pieces. What times itself 4 times would give you an x to the 12th? How many would have to be in each of those pieces? Well, think of your rational exponent. That would be the same as x to the power over root. So x to the 12 divided by 4, so x to the 3rd. In other words, if I did x to the 3rd times itself 4 times, that should give me x to the 12th. And sure enough, that makes sense. It's divisible. Think of it as a rational exponent. It makes it a lot easier. Let's talk about our last one, just as a warm-up here. Negative out front, totally cool. Just means your answer is going to be negative. Sweet, negative answer. Now this one we're talking about, can I take 21 things and break it into 3 groups? So that means what times itself 3 times would give you x to the 21st. So again, let's think of it as a rational exponent, power over root. 21 divided by 3, that would be x to the 7th. And again, if you think about that, x to the 7th times itself 3 times, 7 plus 7 plus 7 gets us to that 21. So trying to figure out how to simplify really comes down to taking that total underneath and breaking it into however many pieces, whatever that indice is, to see if we can do those simplifying. So thinking of it as a rational exponent really does help to be able to do that. So hopefully that's some good warm-ups for you for understanding how to work with exponents and rational exponents specifically for our quiz.